We're going to take a look at graphing this idea of the logarithmic function. And remember that the logarithmic function is really just writing an exponential in terms of the exponent as an output. So what it really ends up being is the inverse of an exponential function. So we're just going to take the basic parent graph of the logarithmic function, which we're going to say is the log of x. And remember that the log of x is really log base 10. This would be the log that is on your calculator. And so if we think about the fact that it's an inverse, remember that inverse functions are those that are really just flipped over this y equals x line. So if you think of the exponential function 10 to the x power, it's going to have, that horizontal asymptote at y equals 0, and it's going to be fairly steep. So if we do the same thing and think about it from the same perspective of flipping it over, the logarithmic function or the log of x is really going to be now a vertical asymptote at x equals 0, and it's going to head off into the right, and it's going to it's probably going to look like that. So one of the things that we want to pay attention to is that the calculator will only do logs that are base 10. So some of the graphs that you're going to see today, we're going to either need to think of the inverse and then just flip them, and you'll see me demonstrate that, or in this case, we can use the Desmos calculator because it does allow you to change bases. And for many of the practice problems that you're going to do, I would recommend using the Desmos calculator here. So let's just take a look at a couple of these examples, and then we'll talk about what it looks like on the Desmos calculator as well. So let's think of the log base 2 of x, and we're going to think about what that inverse looks like. So that's really 2 to the x power, because the base is 2, and 2 to the x is the inverse of thinking of the log base 2 of x. So what is 2 to the x power? What does that look like? So that exponential is going to, I'm just going to do 3 points here. And so if you put, 2 to the 0, it's 1, 2 to the first is 2, and the 2 to the negative 1 is 1/2. So what we can do is we can think of the log base 2 of x as just the inverse. And remember when we did inverse functions before, that we just flip the x and the y coordinates. So instead of negative 1, 1/2, we're going to write it as 1/2 negative 1, and 1, 0, and so on. So when we graph this, notice that this is a graph that again now has a vertical asymptote. And so let's think about some of the things that have changed. Instead of a y-intercept in the inverse 0, 1, now we have an x-intercept 1, 0. So let's think about the domain and range. In this case, the domain is now limited because notice that nothing exists to the left of 0. So when we think of the domain is going to be from 0 to infinity, because again, we don't include 0, so I use a parentheses here. And the range is going to be unlimited, because notice that as you approach 0, it goes down. And as you go to the right, as you approach positive infinity, it goes up. So when we look at end behavior, notice that we kind of have to fill in when it goes to positive infinity, and that is when it goes to the right, towards infinity. And then it goes down, the function goes down when you approach 0. So notice that we can't go any farther to the left than 0. And so then just a couple other notes, then the x-intercept is going to be 1, 0, and the asymptote is going to be x equals 0, because it is a vertical asymptote. So vertical asymptotes, remember, are x equals values. So if I jump to the Desmos calculator, I want to show you how you would graph log base 2 of x. And so I suggest using the keypad here, and underneath functions, Okay, and then underneath miscellaneous functions, notice that we will have an option. This is log base 10, and then this is log choose whatever base you want. And notice that the cursor now is down in the subscript here, so you can type it in as 2. And then we can just type this in as x. And that would give us our function. So if I get rid of this keypad, notice that you're going to see the same function as well. Here's the x-intercept, and then if you wanted to find other points, you could do that as well. So I suggest using this as a tool today. That's going to be very useful. So the next example is going to be log to the 1/3 base. So again, this is a base that's smaller than 1 to the x power. So again, let's take a look and consider what is the inverse. So the inverse of this is going to be 1/3 to the x power, which is going to be an exponential decay function. So we're going to look at the inverse. The log is really the inverse of that exponential decay. So let's see what the inverse is, or the exponential is first. And so, 1/3 to the first power is really 1/3. 1/3 to the 0 is always 1. Anything to the 0 power is 1. And then 1/3 to the -1 is actually 3. So let's go ahead and then use the inverse, the idea that we can just take the table and flip it. Just flip the x and y points. So this becomes 3, -1. And then 1, 0, and then 1/3, 1. So if we graph this, notice that this exponential decay actually ends up looking a little bit different because again, it has a vertical asymptote at x equals 0. However, instead of increasing, this is now decreasing. Right, so with that, notice that again they go the same direction. So even though the values are inverse, they don't inverse direction. Okay, so the domain here is going to be 0 to infinity, and the range is -infinity to +infinity because we have it continues to decrease as you go to the right. So again, it increases this time as you go towards 0 from the right with that. And then it goes to -infinity as you approach +infinity. So as you go to the right, it goes to -infinity. It's decreasing. The x-intercept again is going to be 1, 0, which is the inverse of the exponential. And then the asymptote again is going to be x equals 0. So again, some of the characteristics you need to be able to just point out, and you can certainly see this on the graph if you use the Desmos calculator here. So in these last two examples, I want to demonstrate that you can use the same transformations that we did with all of the other functions that we've studied so far this year. You can do this with logarithm functions as well. So the first thing that you want to notice is in number 3, log base 4 of the x minus 1. Notice that we're subtracting 1 from the x. It's inside the parentheses. So that tells us that, remember, that's going to be similar to an H transformation. And so really, if we think about that minus 1, that is going to be a shift to the right 1. And so when we think about this, what we want to do is find the inverse first of the exponential, and then take whatever we've done and shift it. Okay, so we're going to start with just 4 to the x power, and that's going to be the inverse. And so here's our this is the graph of the exponential. Okay, now we're going to take the inverse to find the log base 4 of x, and we're going to take that and we're going to flip those points, and then we're going to take these and we're going to shift these to the right, and we're going to shift them to the right 1. So keep that in mind as we are doing that. So we're going to take 1, 0, and we're going to shift that to the right, so that ends up being 2, 0. Right? We end up taking 4, 1, shift that to the right, so it's 5, 1, and then take 1/4 to the -1, and that becomes 1 1/4. So what we end up with is a graph. Now notice where the horizontal asymptote is. This has actually been shifted to the right 1. So because it's a vertical asymptote, that gets influenced by shifts left or right. And so we end up with this graph here. That and again, if you graph it on Desmos, you can just think of it a sketch of this. What we're really curious about is the characteristics. And so if we think about the domain and range, the domain here is not 0 to infinity because it's been shifted. This is actually going to be we're actually going to go from 1 to infinity. With our domain, and then our range, however, is still increasing from -infinity to positive infinity. So it's increasing from that. Now if we think about the end behavior, obviously as you move to the right it increases, and as you go to the left and you have to stop at 1, so it goes to 1, that is going to be going to decrease to -infinity. The x-intercept is going to be now 2, 0, not 1, 0, because notice it was shifted. And then the asymptote, as we said, is going to be x equals 1. So keep in mind what those characteristics are as we're thinking about each of those different parts of the graph. Okay, so then the last one we'll look at here is the log base 3 of x, and that's -2. Now notice that this is not inside parentheses, so that means that this is going to be a k shift, which means that this is a shift down. So this function is shifted down 2 with that. So let's take a look at the inverse first. 3 to the x is the exponential that goes with this. So if we just look at the kind of the 3 main points, or 3 easy points for that. So we're going to take those and we're going to flip them. And then what we're going to do is, once we flip these points to give the log of x, we're going to shift it down. Right? So all of these then get shifted down 2, which means that the y coordinates are going to be changed. So when this gets shifted down, notice that the vertical asymptote actually doesn't change here. So vertical asymptotes don't change for shifts up or down. They stay exactly right at x equals 0. If it's moved to the left or to the right, then it does change. Okay? And then, notice that if you had numbers out in front, that would also stretch it out, but we can still see that. So the domain and range actually don't change much from the parent graph. 0 to infinity is the domain, and -infinity to positive infinity is the range. And if we look at the end behavior, notice as you move to the right, it's increasing. So it goes to infinity, and as you go towards 0, it decreases. Now, this one you probably could look up on Desmos to see where it crosses the x-axis. You'd have to extend your table a little bit if you were doing it kind of by hand. But it does end up crossing at 9, 0. And as I said, the vertical asymptote, however, doesn't change from the parent graph. It is x equals 0. So the best strategy, I think, is to graph it on Desmos and then pick and take a look at some of the different parts to that, and then you'll be asked for some of those characteristics in the practice problems as well.